Hey everyone, welcome to episode 6 of How to Build a Delta. So in this episode we're going to finalize a couple things with Klipper that I didn't talk about in the previous episode in the config file. We're going to talk about rotation distance a little bit, and we're going to talk about Prusa slicer, fork, which is called super slicer, and Cura. So first let's go here to my mini that we're building. We're going to go back into the printer config. And the first thing that I want to talk about is thermistors. So obviously you're going to need to tell printer or Klipper what thermistor you're using for the extruder, and also the hot bed as well if you have a heated bed. So I'm using a Beta 3950 for my extruder. If you go to Klipper's GitHub, there is a thermistor Python file under Clippy extras, and at the very bottom it just gives you the default thermistors that Klipper supports. So you can see here's the Beta 3950. These are the most common type of thermistors. It's very easy. You just copy the name here and put it directly into your config file. Same thing too for if you were converting over like another printer that you had. Maybe you want to try Klipper out on like an Ender or something. You can go to the example configs here again on Klipper's GitHub. Go find the printer that you're converting. Let's say you're converting an Ender 3. And you can find out what thermistors are being used for the hot end and also what thermistors are being used for the heated bed as well. Klipper also does have one-line PID tune for the extruder and hotbed as well. If you go into the actual Klipper installation guide here, there is an actual command for PID tune, very simple. It's one line. As well as how to actually calibrate rotation distance. So rotation distance is E-steps if you're coming from Marlin. So you need to tell your printer basically how much to move the stepper to move a certain distance. So it's called rotation distance in Klipper, and it's very easy to calculate. For the most part, X, Y, Z, or XY, I should say, is very straightforward. It's generally always only two numbers, and you can see that in an example config of like a printer here. So like an ANET A4, let's say, just as an example. Here's a rotation distance of 32. That's basically your standard belt-driven rotation distance for steppers, 32. The other one you'll see is 40. Depending on what type of steppers you have, there's two different kinds generally. 0.9 degrees, I believe, and 1.8 degrees. So that'll depend on what your rotation distance is. Generally, it'll say when you order the steppers what their rotation or what their angle is, 0.9 or 1.8. And this, you can actually see this in here. It'll actually talk about what kind of steppers you're using, and it's very easy to calculate. But like I say, you can just pull it directly from another config file. For the most part, I use the same in all my printers. So you can see this printer here, I believe this is 1.8 degree steppers are what I'm using. So my rotation distance is 40 for all of my steppers. Okay. You also have to calibrate rotation distance for your extruder as well, which Klipper actually outlines here. There's a very simple guide. It's very similar to Marlin. Essentially, you mark a piece of filament with a pair of calipers right outside of your extruder, and then you tell Klipper to extrude that amount of filament, and you find out how much it did, either more or less. And it's very easy to figure that out. As well as you can go into one of these configs if you know what type of extruder that printer uses. So for instance, I know that the Tronxy X5SA Pro, because I've had one, uses a Titan extruder. So I can go in here and I can actually find out the rotation distance of my Titan. You can see right here. You can also specify the gear ratio too, just to make it a little bit more accurate. Same thing for like a BMG dual gear extruder. You can just Google Klipper BMG dual gear and you'll get a close rotation distance. You can fine tune that, like I say, with this once you've actually put that number in. but that'll give you a good start on how to actually calibrate rotation distance. It's very straightforward. So that's all we wanted to talk about here. For the most part, the config file is now done for our actual delta. We can now touch on slicers briefly. Just because I'm already screen recording my computer, we might as well just quickly talk about two slicers that I primarily use and show how those interact with Klipper. So the first one we're going to talk about is Super Slicer. Now, this is a fork of Prusa Slicer, and I think it's based on Slick 3R or Slicer, however you want to say that. But it has some really great features. You can paint on supports. This is, of course, completely free. And this can very easily export G-code directly to your printer. You don't have to save it and then copy it over or upload it, which is really, really handy. So you can see here, I've actually set up a profile for my Phoenix Mini. If we go to my printer settings, you can see I've told Prusa Slicer that I'm using Klipper as a firmware. And you can see here, I've even set up thumbnails. This will actually send a thumbnail as well, included in your G-code, so that Klipper can show you what you're actually printing, which is really, really handy. So on the Mainsail website, there's an actual section for thumbnails, and it tells you to put this information in. It's just 32 by 32 for small. Big is 400 by 300, and I've chosen a color. This is kind of the theme of my printer, silver and gray. And then what I've done in my physical printer settings, I've actually entered in my host type, which is Klipper, and the IP address. So now, when I slice a file like this, for instance, this calibration cube, I can just press on this little G in the bottom right here and click OK, and it will actually send this directly to my printer. If I go to G-code files, here's my cube. And it'll even tell you Super Slicer was the slicer that sliced this, when you uploaded it, a whole bunch of information, how much filament's being used, print time, all that kind of stuff. It's very, very nice. So that's Super Slicer. This is my preferred slicer. And you can use whatever works best for you. So you don't have to use Super Slicer if you don't want to. You can use Cura as well. I do have the Phoenix Mini set up in Cura. It's very straightforward to set up a profile. I just chose custom printer. I said this is 180 millimeter round bed, 180 millimeters tall, and I chose a couple settings here. I'm using direct drive, so I just turned down my retraction distance to 2. I could probably even set this to 1, and then I can slice whatever I want. I also have installed a third-party plugin called Cura Moonraker, and this allows me to upload directly from Cura to my printer as well. There's an extra step. You do have to install the plugin and configure it, but you can still actually send your G-code directly to Klipper as well in Cura. So whichever slicer you like to use. Simplify 3D, I don't know if it has a direct upload to Klipper. I don't use Simplify 3D, but it does definitely work with Klipper if that's your slicer of choice. So you could research to see if it actually uploads directly to Klipper. But that's going to wrap up episode 6. I wanted to just make a really quick one just to kind of finalize our config file and also talk a little bit about slicers and how they work with Klipper. In the next episode, it's most likely going to be the final official episode for the Delta build. We're going to actually use our hot end probe, and we're going to actually calibrate the printer, and Klipper's going to calculate all of the arm lengths and everything like that so that we can start printing a calibration cube. If you have any questions, please comment below and definitely subscribe. I've got more printers coming. I have an Ultimaker 2 that I'm converting over to Klipper, and I also have an Ender 3 that has Klipper on it. All right, thanks again, everyone.